Hello student, myself is Rahul Kumawat. Today we are going to start a different chapter called binary search. The binary search is the most optimized searching algorithm that we are going to study in data extraction and algorithm. So first of all, we need to start what the searching is. What is the searching? Search means to find out the particular element in the particular array or string or even any data structure. For example, if array is given to you is 5, 7, 9, 11, 13. Suppose this is an array which is given to me and the target element is 9. We need to find that this particular target element occur in this array or not. So this is our target element. Okay. In that process, we can start to search linearly. That is called linear search. And we can start to search binarily. That is called binary search. What is binary search? I will tell you each and everything. So there are two type of searching algorithm that we have. The first is your linear search and the second one is your binary search. In the case of linear search, what we are doing? We are going to traverse the array. So in this case, we are going to traverse the complete array starting from I is equal to 0 to I is equal to n minus 1, wherever the n is the size of array. So if we traverse the array and finding the particular element, the target element is there or not, this is called the linear search. So first of all, I am going to write pseudo code in the linear search. Then we will start to study about binary search. So for that particular element, for example, if there is a function and suppose we need to find out the element, so that's why it will return boolean function. Suppose that is a vector which is given to us, vector integer array which is given to us, and then integer target that is also given to us. So in this function what we are doing is we are going to traverse the array. So for that particular element integer I is equal to 0, I is less than array dot size and I plus plus, and in this case if array of I is equal to target, if it is so, then we return what? Then we return true. Or if it does not return true in the entire array, it means what? It means it does not have that particular element. It means it should return false. And that is your particular code. If we are going to think about what is the time complexity, so the time complexity for this is what? The time complexity for this is order of n. Why this is order of n? Because we are going to traverse from starting to ending, so that's why it is order of n. And the space complexity is order of 1, because we don't require anything in order to store it. That's why the space complexity is always order 1. So in this case, time complexity is order of n and the space complexity is order of 1. But now we are going to start binary search. Suppose we don't want to use linear search in this case, we want binary search in order to find out the particular given element. So yes, that is called binary search. In that particular binary search, we start from left part and the right part. For example, what we are going to do in this case is, for example, there is a integer I which is equal to 0. There is a integer G that is array dot size -1. It means it will be what? It will be the leftmost part, and it will be what? It will be rightmost part, rightmost index. That is rightmost index and that is leftmost index. Okay. Yes. Now the array which was given to me was the array which was given to me was 5, 7, 9, 11 and 13, and the target element is 9. Target element is 9. The first of all, this array is shorted. The array is shorted means what? It means if we move from left part to right part, the number of element, the number of the element, the number in that particular element is going to increase. For example, if it is 5, then it is 7, that is 9, that is 11, 11 is greater than 9, 13 is greater than 11 and so on. And if we move in this direction, then number is in decreasing order. And here the number is in increasing order. And here the number is decreasing order. So what we are going to do in this case is, we are going to start from the leftmost index, that is I, and the rightmost index, that is J. Okay. And we find the mid element of that particular I and J. So suppose the mid element occur here. Suppose the mid element occur here, that is 11. Now we compare 11 with the target element. Suppose that is 9. So 11 is greater than 9. It means we require lesser than what we get. It means we require lesser than 11. In order to get lesser than 11, we should move in this direction. It means what? It means now J become M minus 1. Now J become this and I become this. So our portion of array now becomes shorter. It becomes 5, 7 and 9. Now our array becomes this only. It reduced the portion of searching in the particular array. Suppose again we start, it is I, it is J. Suppose that particular mid element of I and j occur here. That is again what? That is again m. Now we compare that particular number with the target number. It means 7 should be compared with 11, and 7 is lesser than 11. Sorry, 7 should be compared with the 9. 7 should be compared with the 9, and the 7 is lesser than 9. It means we require more than 7. In order to get more than 7, we should move in this direction. It means what? It means now our new I should become m plus 1. So now our new I should become this only. And in order to doing so, we get what our required element is. And suppose if I is greater than j, suppose this equation become I is greater than j, it means we have traversed the entire array, but we don't get any element. For example, we suppose in that particular question, suppose we want to get find out is our target element is 8. Now I should become this, so I and j will both become 9, and again 9 should be compared with the 8, and 9 is greater than 8. It means our j should come in the left direction. It means our j should come in the left direction. J now become this. Up here your I is greater than j. It means we have traversed the array completely. If we have traversed the array completely and don't get the element, it means there is a chance that the element that we require does not exist in this array. Does not exist in this array. So this is called the binary searching. Now in this binary searching also, what we get is, suppose this is your array. Here suppose 0, 1, 2, this is index, 3, 4, 5 and 6. Here suppose this is I, then this is j, and after finding the middle element, suppose middle element is this 0 plus 6 divided by 2, which is 3. So middle element is 3. So yes, that is become now m. Now either you should select these portion or that particular portion. So now our new array will become I to m or m to j. That will become our new array. And again this will be bifurcated. Again this will be bifurcated. This will be bifurcated in two parts. Again this will be bifurcated into two parts, and so on. It means in each and every step our array will become bifurcated. It means array will become shorter. So for that particular, in order to get the time complexity, what we require is, for example, first of all it is n, then it is n by 2, then it is n by 4 because it is bifurcated, then it is n by 8, then it is n by 16 and so on. So yes, that is called n into 1 plus 1 by 2 plus 1 by 4 and so on 1 by 16. So here this is called log of base 2n. This is called time complexity. Time complexity of the binary search is log of base 2n, and the space complexity is what? Order of 1, because we don't require anything in order to store. So that's why the space complexity will become order of 1. So yes, this is about your binary search. In the next part, we will write the pseudo code of binary search also. Thanks for watching.